Let's continue with Newton's laws. Question 3. A 5-kilogram block resting on a rough horizontal surface. All right, maybe this will be important. If it's resting, I already know velocity is 0 there. Initial or final, don't matter at this point. All right, it's connected by a light inextensible string, a string that does not stretch, passing over a light inextensible frictionless pulley to another block of mass 2 kilograms. This is 2 kg. The 2 kg block hangs vertically as shown in the diagram below. All right, and then here's a 5 kg. This is a 2 kg. And then I haven't heard anything about rough surface. Okay, a force of 60 Newton, which is this one here, at an angle of 10 degrees, to the 5 kg block at an angle of 10 degrees to the horizontal, causing the block to accelerate to the left. It's applied, that force. So this is going to cause the object to move towards the left, like how I did here. I indicated the direction of the acceleration. I indicated the direction where it's moving because it tells me I take the forces in the direction of motion minus the forces opposite the direction of motion. All right. Then they say the coefficients of kinetic friction. So they're giving me the coefficient, that mu, kinetic friction on this one. Between the 5 kg block and the surface of the table is 0,5. Ignore the effect of air friction. All right, so I'm not worried about anything much. All I need to do is to do all the forces. So this is the direction of A, the acceleration. So if the 5 kg will be moving to the left, obviously the 2 kg will be moving upwards because it's being pulled upwards. Do you agree? Yes. All right. Now, don't even ask them anything. Just go do all the forces here. I'm going to start with the 2 kg. Starting with the 2 kg, there's a downward force, which is the force of gravity or gravitational force, or what you normally call the weight of an object. By now, you should know better. We're going to take 2 times the 9,8. All right, 19.6. And then there is an upward force, which is the tension force. Now I want you to understand that this blue line represents the same string, meaning the tension is the same. All right. So the 2 kg block is done. It's got those 2 forces. If they ask me a free body diagram, I'm going to put a dot there. There's an upward and a downward force. That's it. So let's move to the other one. Then we go to the 5 kg block. There is a tension in that direction also. But since they specified there is friction, so friction opposes motion, so there'll be a friction there. We're going to have to find that friction value there. All right, so let me just go put it right somewhere here. All right, we'll come back and put it in a nice place. All right, and then again, when you look at this object, there is a downward force. Again, there is a force of gravity on that one there. Force of gravity, by now you know better. It will be mass 5 times 9,8. I believe it's a 49 Newton. And there is an upward force, which is F subscript N, or the N, which is the normal force. You can see. All right, now we come to this one that is at an angle. We're going to have to break it into its component, meaning there is a force that's pulling towards the left, and there will be a force also pushing upwards. There we go. So the green one, okay, let's start with the blue one. The blue one, it's now opposite to the 10. It takes the sign. So that blue one, so I'm just gonna give it the value. It's 16 multiply by sine. Anything that is opposite will take the sine. So it will be 60 times sine of 10. If you want to do the working out for that, well, we can just do it and round off to 2. All right, it's 10.42 newtons. Now we go to the green one. The green one, it's also going to be 60, but this one will use a cos of 10 newton. So let's work it out also. 59.09 newton. All right. So this one is the one at the angle. So at this point, we are sure we have done everything. Now, without them even asking me anything here, I need to give them that frictional force. Yeah, I think here we'll have a nice space here. If I squeeze it in here, we'll put it as friction. Remember, friction, according to the equation, friction equals to mu multiplied by the normal force. The mu has been given to us. If you didn't see it, there it is there. It's 0.5. So let's go substitute it in there. 0.5 times by the normal force. I want you to be careful now. Normal force is vertically upwards. You must take all the forces which are vertical. The one which are pointing vertically up, vertically down. Vertically up, vertical down. Only on the 5 kilogram. There are 3 forces. There is the F, this one, the normal force. There is this one here, the force of gravity. There is this blue one also, pointing up. So, normal force plus the blue are pointing upwards. They must equals to the downward force, the 49. So don't make that mistake. So now, to get that normal force, so I was going to write F normal plus the blue upward forces, which is 10 point, or forces which are pointing upwards rather, must be equals to forces which are pointing downwards, must be equals to the 49 on this object only, because the friction is on that object. Then you want to transpose that and get the normal force. Since you know your mathematics, it will be 49 minus 10.42, giving you nothing else but normal force. In your case, if they were to ask you, it will be 38.58 newton, and that is exactly what I want to go put it here. So I'm going to put 38.58 to get my frictional force. So when I calculate that, frictional force becomes 19.29 newton. So now I can go slot it there. Like I said, I was going to put it. It's going to be 19.29 newton. Now we're good. We show all the forces, which is free body diagrams of each block. Now, we are now going to do the net force of each one of them. So first, let's start with this little one here. It will be T minus 19.6. So the first one will be tension, top, the one that are pointing up, minus the 19.6, which is pointing down, equals to MA. I know the mass is 2, and then times by the acceleration, that's equation 1. So this one, because the object will be moving towards the left, everything that points to the left, minus everything that points to the right. So what points to the left is only this one here, the green one, 59.09. So I'm going to write 59.09 minus the one pointing to the right, which will be that T, the tension, and then minus is another one, the friction, 19.29, And then we just have to verify, make sure there isn't another. We are not missing anything. Equals to MA, the M is 5, and then times by the acceleration. So according to the mathematicians, this will be equation 1, and this will be equation number 2. I'm going to use 1 because 1 looks better. All right, from equation 1, I don't need to solve from equation 1. Now you know better. So T is going to be 2A plus 19.6. And all of that needs to go in here. Put them in a brackets because the sign will affect 2A and 19.6. But I'm going to put them in there already changed, those signs. So it will be 59.09 minus 2A already changed minus 19.6 minus 19.29 equals to 5A. This time I need to take this A will go over there. You can see it is going to be 7. Then these are numbers, add them together. Let's do so. 20,2 on the other side, and the other side is 7A. Divide by 7 both sides. You're going to end up with acceleration. I believe it will be 2,89. Am I right? Meters per second squared. Now listen to me. For this 5 kg, it will be to the left. For the 2 kg, will be upward. Then let's find the tension. So we can figure out what tension is. So we are going to write T equals to, which is this one here, is going to be 2, open the brackets. We're going to slot in 2,89 there, and then plus 19.6, and therefore the tension becomes, we get a whopping 25,38. That will be newtons. All right, let's read the questions because I'm just showing you the strategy without even reading the question. They say now, draw a label free body diagram showing all the forces acting on a 5 kg. Of course, you're going to have to do it also on a 2 kg. So we did all. We don't even care about these guys, what they're going to say. Calculate the magnitude of the vertical component of the 16, meaning the blue force, which is 10,42. We got it. The horizontal component, which is the green one, 59.09 Newton to the left. There we go. And now they say state Newton's second law of motion in words. In the first video, we stated here because they asked me to do it. We did it. And then the next one says calculate the magnitude of the normal force on the 5 kg. There it is, because this is the route. It's a route, it's a route, you have to pass through it. It's a path. You can't do any other thing without passing it. That's why they're asking you what's along the pipeline. Calculate the tension. They could have asked the acceleration as well. We got it, and we gave them even an extra bansela, which is the tension. This question is done.